Hello friends, welcome to Vigyan Foundation's Higher Academy and you are watching my YouTube channel Vigyan Foundation. So friends, today in this video we will try to understand one new subtopic in physics, that is current electricity part 4. So friends, following are some of the common components used in electrical and electronic circuits. So let us try to understand one by one. So friends, let us try to understand the first electrical or electronic component, that is the resistor. These are the components which control the flow of electric current and the potential difference passing through a given circuit. The unit of resistors are measured in terms of ohms or in terms of kilo ohms. These resistances can also be measured with the help of a measuring instrument called as ohm meter. So friends, let us now study about the resistors in detail. So let us try to understand how to calculate the values of a given resistor by using this figure. So initially the values of the given resistors are calculated by using a color coding system. The color coding system is clearly explained in the figure as shown. So let us try to understand the color coding system at first. So you can see, friends, let us take one resistor as an example, that is of 120 ohms with 5% of tolerance. So here, how can we calculate the resistance of value 120 ohms with 5% tolerance? So let us try to understand the color codings and its bands. So you can see, friends, in this particular resistance which is having the value of 120 ohms with a 5% tolerance, which is shown at the top of the color coding system. So here one brown colored band is there, then the second one you can observe one red color band is there, and the third one you can observe that it is a brown colored band, and the fourth one you can see it is a golden colored band. So one by one we shall try to understand the meaning of these bands. So here, friends, let us see about the first band, that is the first color band. So here we can see that the first color band is having certain colors which starts from 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So in future, whenever we need to calculate the values of resistances, we have to follow the sequences given in this particular color coding system. So what does this mean? Let us try to understand one by one. So here the first color band, as shown in the figure, you can see it is having a brown color. So this brown color means, as I have already told you about the numbers like 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So friends, then just try to look at the colors which is right on the next side of these numbers. So as we are seeing in the figure that 0 is along with the first color band, that is black, and number 1 is just representing the next color band, that is brown. Similarly, you will see number 2 which represents the next color band red, and 3 represents the color band orange, 4 represents the color band yellow, 5 represents the color band green, 6 represents the color band blue, and 7 represents the color band violet, 8 represents the color band gray, and 9 represents the color band white. So what does this mean? This means that whatever the first color band is used in the given resistance will have to be considered as the respective numbers. For example, if the first color band is in brown color, then the number which is to be taken for the first color band is 1. So you will consider the number 1 at first, and then we will come to the next color band, that is the second color band, which is shown in red color. Then what does this mean? This second color band is again shown in the second column of the color band system. So again, by following the previous sequence, we can see that the second color band, which is shown in red color, is denoting the serial number 2. So by taking this number 2 along with the previous number 1, which was for the first color band, now we have two numbers, that is 1 and 2. So for calculating the values of the given resistance, we have to take the first color band serial number, that is 1 at this particular point, and then the next serial number which is to be taken here for this particular resistor is 2, which represents the red color as per the color coding system. So in this way we have 1 and 2 for its first and second color codes. Then the next color band is the third color band, which is represented with a brown color. So this color band will be now showing us the multiplying factor. As you are seeing this figure, the third color band is indicating one another term called as multiplier. So friends, the color coding system will follow the same sequence as mentioned earlier, and here in this particular multiplier system, we have to consider one another multiplying factor, like you will be seeing at the right side of this color coding system, that is along with the multiplier factor, that is number 1, that is black, number 2, that is brown. So here in this multiplier column, you can see instead of number 2 for brown, here we have taken 10 to the power 1. That is, it multiplier value is 10. And for red, it is 10 to the power 2. Means the multiplying factor will be 100. And for orange, it is 10 to the power 3. Means the multiplying factor is 1000, and so on, friends. So in this way, for calculating the value of this given resistor, now we have to consider the third color band also. So the third color band in this case will be now 1 into 10, that is the multiplying factor will be 10. So here in all, how will we be calculating the total value of the resistors? So the total value of the given resistor can be calculated in this way. That is, the first color band, as we have already seen earlier, was number 1 as per the color coding system sequence. Then the second color coding sequence was number 2, which represents the red color, and the third band, that is the color band, is represented with the color brown, which is also called as the multiplying factor. So this multiplying factor in this case is now taken as 10 to the power 1, which is equal to 10. So finally, how will we be calculating the total value of the resistor? By adding and multiplying these things. Adding in the sense, we have to just consider the first color band 1, then the second color band 2 in sequence. It becomes 1 and 2, that is, we will be calling it as 12. So this 12 is to be multiplied with the multiplier factor that is 10. In this way, the first color band and the second color band multiplied with the third color band will give you the total value of the given resistors, and that is nothing but 12 into 10, which is equal to 120 ohms. This is about the calculation of the given resistor. Then the last band is of golden colored band, which is shown in the figure of this particular resistance. So this golden colored band just indicates the tolerance limit of the resistance. So this golden color band has a tolerance limit of 5%. And if it is in silver colored, then the silver colored value will be of 10% tolerance. That means the value of the resistance can vary in between 5% to 10%, that is in case of gold and in case of silver colored bands. So friends, in this way you can also calculate one another resistance which is given for you, and in this way, we are going to complete the figure and the topic about the resistors. Now friends, let us see about the capacitors. The capacitors are two-terminal electronic components. They can store electrical energy for a while and then can transmit the same energy as and when required. The capacitors may be made up of ceramic or electrolytic. So you can see the capacitors in the given figure and the types of the capacitors as shown in the figure. Then let us come to the next basic, which is called as inductors. So these inductors are also two-terminal electronic components that can store energy for a while and in a magnetic field. When an electric current passes through the given circuit, the function of the inductor is to block the alternating current and to pass the direct current. The inductors can also be combined with capacitors to make tuned radio and TV circuits. The inductors are shown as in the given figure. Now let us come to the next topic, that is diodes. So most of the diodes are made up of semiconductor material such as silicon, germanium, etc. The function of the diode is to allow the current to pass easily in one direction and to oppose the same current flowing in the circuit in the opposite direction. The symbol and the physical representation of diode can be seen in the figure given, and in this way we complete the topic of diodes. Then friends, now let us see about the transistors. So most of the transistors are made up of semiconductor materials such as silicon, germanium, etc. These semiconductor devices can behave like a conductor and as well as like an insulator, and can also act as switches and amplifiers. This can also be further classified as bipolar junction transistor, that is called as BJT, and field effect transistor, which is also called as FET. So the figure of the transistor can be seen as shown. So friends, by now you might have understood my subtopic current electricity part 4. So if you have understood my subtopic current electricity part 4, then please like and subscribe my channel.